Yes. Okay. A very good afternoon, everyone. I, Mrs. Bhagilakshmi Behera, on behalf of Siksha O Anusandhan University, welcome you all to the third day of AICT-sponsored ATAL FDP on Advances in Artificial Intelligence. Hope you all have gathered valuable information in last sessions. We'll start today's first session, and we have the resource person with us, Professor Kandak Kumar Sharma. Once again, a very good afternoon, sir. I deem it a great opportunity and proud privilege to introduce the resource person of this session, Dr. Kandak Kumar Sharma. Before all of you, Dr. Sharma is currently working as professor and head of the Department of Electronics and Communication Engineering, Guwahati University. He received his PhD in the area of mobile communication in 2012 and MTech in 2005 from IIT Guwahati. His research interests include deep learning, wireless communication, speech processing, and antenna design. He is a senior member of IEEE. Sir, on behalf of Siksha O Anusandhan University, I welcome you to this IDP. It would be the matter of immense pleasure for all of us to hear from you. May I please request you to deliver your talk on cognitive consideration in wireless network, current trends and practices. Thank you, sir. Now it's over to you, sir.
Yes. I'm. Thank you for the nice words. I will now start my presentation. Let me share. I will be sharing now.
The participant during the session, please be muted. If there is any query, you can put the query on the chat box.
My slides are visible.
Yes, not now, sir.
Oh, okay.
Yes, sir. Now it is visible.
Okay. So let me start my presentation. So my talk today is titled Cognitive Considerations in Wireless Networks, Current Trend and Practices. So let me go to the plan of the presentation. So the plan of the presentation, first I shall be briefly speaking about the wireless networks, then the challenges that are coming across in the next generation wireless networks, different cognitive methods, and then a brief review of how the cognitive methods are used in the wireless networks. Now, we all know that the key feature of the wireless communication is its mobility. It's not affixed to one particular location, for which we can have voice, data, text, video simultaneously while on the go. Now, worldwide, for several decades now, a goal is to have a minimum of 1 megahertz bandwidth, and with 1 megabits per second continuous data rate as a common standard. So the technology has grown to reach this particular common minimum goal worldwide. 1 megahertz bandwidth at all points of time with a data rate of 1 megabits per second for all wireless connections in this world. So we know that the basic mobile communication concept is based upon a linkage between the public telecom switch network and a mobile network, which is connected to a number of base stations. The base stations are connected to the subscribers at fixed cell sites. These are called cell sites. These are fixed, smaller size geographical locations called cell sites are looking after or look after the subscribers' requirements, and they will be through the mobile telecommunications switching center connect to the public telecom switching network. So this particular means of networking between multiple types of network topologies help the subscriber to start a communication and reach a destination. Now with the rise of the wireless communication, the cellular radio concept started, that had the primary aim of replacing a big transmitter with several smaller transmitters, receivers at smaller geographical localities. The smaller geographical localities with a structure similar to a biological cell gives seamless connectivity. So when a person in a vehicle moves from one location to a different one, that particular person crosses or may cross several cell sites like cell A, cell B, cell C. And while the person moves from cell A to cell B and from cell B to cell C, the control of the connection is passed from the transmitter or the transceiver or the base station at cell A to cell B, then to cell C, and this particular method of seamless connectivity goes on continuously. This is the basis of the cellular radio transmissions. Now, in a cellular base station, there is a cell, and the cell will be covering a particular locality by the help of a transponder. The cell will have a antenna structure that will point in three directions, meaning that each of the structures will be providing a 120-degree coverage. So each of the cell will have one of the antenna structures for control, one for voice, and two for receive. The same structures will be also configured for transmitting and receiving data and text streams. So let's roughly go through how the cellular system developed. So a big transmitter was used previously to do transmission all throughout a geographical locality. Now the big transmitter meant that lots of power is required for doing the transmission, and when on one day that particular transmitter is not working, or that transmitter requires servicing, the complete communication comes to a halt. So therefore, this particular big transmitter is replaced by several smaller transmitters distributed at different parts of the geographical locality. So it is replaced by a structure like this, cellular structure. So for these are all these small blocks resembling the biological cell gives rise to the word cellular. So that big tower is replaced by several smaller towers, and each of these smaller towers are at specific localities at the cells, and with that tower, a small tower is connected or linked a complete transceiver system called a base station. So that way the base stations will be connected to the mobile switching center, and the mobile switching center will be finally connecting to the public switch telecom network. So this way the cellular system develops. Now, while the cellular system works, it suffers the signals that go through the wireless media suffers in its strength. So it shall be suffering due to large-scale fading. Large-scale fading is created when the distance is more. So when the distance is more, we know that the wireless signal will be degrading, or the loss in the wireless signal or the power of the wireless signal degrades with 1 by 10⁴ distance raised to the power of 4. So as the distance rise, there will be loss in the strength of the signal. Then there will be one more type of fading, that is the third small scale fading. This is due to the multipaths that the wireless signal will take. So the wireless signal will have one direct path, and there will be several reflected components. So while the signal goes through the reflected parts, the strength of the signal will fluctuate, will fall, or will rise. So this particular fluctuation too also gives rise to a fading effect. And there is a second type called a medium scale fading. Due to the shadowing. So there can be a high-rise building. There can be hills. So these hills and high-rise structures give rise to a shadow effect, for which the medium scale fading is created. So these three types of fading contributes towards the loss of the signal, and therefore all the technologies that are put there in a wireless communication system are meant to guarantee a proper signal strength, so that the link reliability and the quality of service is sustained. Now, during the last few decades, we have seen that mobile communication has made tremendous progression, starting from the 1G to the 4G. 1G was based on the frequency division multi-SS, with now the 4G is shifting to the OFDMA, that is a orthogonal frequency division multi-SS, which promises true wireless broadband. Its theoretical limit is 100 megabits per second, but in our country we do not get such high speeds. But it has given rise to a lot of capability, because it is providing wireless broadband in true sense, 4G. So between the 1G and the 4G, we saw the developments of the multi-SS technique, like the time division multi-SS, the code division multi-SS, and with the 3G, we saw the use of the wideband code division multi-SS techniques. So these have helped the wireless systems to grow from the 1G to the 4G. Now, in the US, they have commercially launched 5G. In our country too, in the next 6 months, we might see the launch of the 5G. So when we move to the 5G, we will see a lot of convergence taking place. The convergence shall be the meeting of narrowband, wideband, broadband technologies, a lot of personal networks, a lot of last mile technologies, and that will give us a true convergence. So the 5G's promised features are more than 1 Gbps connectivity that will have several small cells, macro cells, micro cells, guaranteeing the link reliability and better quality of service. 5G further promises to use several versions of the multi-in, multi-out MIMO technology to give a continuous broadband connectivity at all places at all times in the true mobile state, which has led to the growth of the mobile worldwide wireless web. So the move towards 5G since is based on several considerations. One of the prime considerations is linked with the technology deployment. So when we move from 4G to 5G, there is likely to be a quantum jump in the technology, and in countries like us, there is a consideration that this move from 4G to 5G shall be based on a lot of software functionality layers. So the basic topology of the networking the basic structure of the networking shall remain as 4G or 3G. On top of those 3G or 4G network structures, there will be several software layers, software functionality layers, which will permit the deployment of 5G functionalities. And since there are a lot of software functionalities are being grown to help the present networks migrate from 3G, 4G to 5G, therefore the use of the AI, machine learning, or the cognitive tools have come to the picture. Now, with this growth of this 4G to 5G or 3G, 4G to 5G, people have found that the complexity and the requirement of better solutions is very pertinent, because due to the growth of the diversity and the complexity of the mobile networks, monitoring and managing the networks have become very difficult. Similarly, resource conservation has turned out to be a very challenging task, and link reliability is to a big factor. Now, for all these critical cases, people have found that the use of machine learning is quite critical, because with the use of the machine learning techniques, machine learning tools, the networks will have all the capability to use the resources in a optimal way. Primarily, people are finding the use of machine learning in the multi-access network radio control layers to be very relevant. People have further found that the machine learning tools will be quite beneficial in malware detection, network planning, management, and so on and so forth. And then researchers have found or have shown that machine learning permits systematic mining of the content from traffic data, and automatically discover the correlations that are too complex for the normal person to extract and learn. So these are some of the benefits that are as part of a machine learning framework, facilitates its use in a wireless communication structure. So we know that last time also I have talked in my slides that the bigger scenario is the AI. As part of the AI comes the machine learning, and as a subset of machine learning, deep learning has developed, which has now provided wide scope for its use in wireless networks because of the huge range of benefits that can be derived from it. So we know that machine learning, we know that AI, machine learning, and deep learning are linked together. All has the aim to develop a set of computational paradigms which will permit the machines to work, react, and learn like the human brain. It needs to have the capability to capture knowledge and make decisions. So we know that machine learning techniques being categorized as supervised, unsupervised, and reinforcement learning have been found to be quite relevant in mimicking biological nervous system and carry out or generate representations, learning through multi-layer transformations, extending across all three learning paradigms, which make it relevant for use in the wireless network domain. We have lately seen that the AI has covered all known domains of our day-to-day life, starting with computer vision, speech recognition, then chatbots. These are all being covered by the AI in different forms. Therefore, we cannot keep the wireless domain in a different place, not to be covered by the AI capabilities. So we have seen that AI, when deployed through the use of the machine learning tools, come to the forefront when used in supervised learning forms and semi-supervised learning form, unsupervised learning form, reinforcement learning form. They are used simultaneously for website classification, then targeted marketing, speech recognition, face recognition, and then dimensionality reduction, then clustering, a huge range of clustering cases, then classification and regression, and so on and so forth. Last time I spoke about it too. So supervised learning is a type of learning that we see in the case of the machine learning tools, where there will be a reference for doing the learning. So if there are fruits, several fruits, and we pick a specific type of fruit, we mark that fruit and give it to the model. The model will try to learn that particular label fruit, and finally will be in a state to detect the learned fruit from a number of fruits given to it. So we know that the ANNs in the feed-forward form, mostly like the multi-layered perceptron, when trained with the back propagation method in several layers, are best form of supervised networks. So, the multi-layered perceptron with the supervised learning, following the backpropagation method, will learn the patterns by following a feed forward and a feed backward flow. Then there is one more type of supervised learning machine learning tool that is called a support vector. This support vector machine is a linear classifier that aims to separate data points that are p-dimensional vectors by the use of a p-1 hyperplane. So the support vectors will form the class regions, and the class regions by doing a similarity match with the class vectors or support vectors. The classification is done by the support vector machine. But for doing that, the support vector machine will require some label data. Then there is one more classifier called the k nearest neighbor. That is a non-parametric mechanism for classification and regression, where no
Sir, your voice is not audible, sir.
Sir, your voice is not audible. Hello, sir. Maybe due to some network issue, sir is not audible. Please be bear with us. Excuse me, sir. Dear participant, sorry for the interruption. There is some network issue at the resource person side. So he will be joined after 2 to 3 minutes, as the problem will be resolved. After that, he will join. Kindly bear with us.
Hello. Yes. Sorry, there was a brief disconnection due to the loss of power. The power was cut. Now I have shifted to the mobile phone. So I will continue from where I stopped. So please bear with me. Okay.
Okay, sir. No issues.
Yes. Yes, slides are coming. Hello.
Yes.
Okay.
Yes, sir. It's coming.
Yes, sir.
Okay. So, so there is one more type of classifier called the k-nearest neighbor classifier. That is a type of classifier used for regression also. But it does not. It is a non-parametric technique, and it needs no consideration requiring the data distribution. Here, this type of classifier works by the use of a voting technique. So the voting technique that pulls the maximum number of positive considerations for a class will lead to the classification within that neighbor boundary. So there can be one neighbor, two neighbor, three neighbor, four neighbor, like that. So that way the boundary coverage will lead to classification and regression. And unsupervised learning, there is no reference. It works simply by generating the clusters. Common features are picked, and that way groups are formed, and cluster centers will be the statistical mean of the samples packed in one particular cluster. So there are several means of clustering. One of them is the k-means clustering, through which the unsupervised method forms the clustering. So that means by the formation of kth mean of a cluster, the grouping will take place. So this way, if there are a mix of colored samples, they can be packed in clusters with similarities of color and shape. There is one more type of classification and regression technique, that is a PCA that will use the principal components mainly for reduction of dimensions relevant for use or larger sets of data. And by the use of the principal components, we can also form clusters. And these two also will not require any prior consideration of the characteristics of the data source. And then reinforcement learning that will use multiple stages of feedback to reach a correct decision. So if a decision is to be made for that particular class, a feedback shall be used at the local level, stage by stage, so till a proper decision or the correct decision is reached regarding that particular sample's nature. The feedback will continue to receive responses, and if the decision is made correct, a reward is fixed. So for a particular class, during a number of cycles, the maximum number of rewards received by a particular class will help in deciding the classification. Now the shift from these machine learning tools towards the deep learning method was, as I had spoken in the last class, is primarily due to the limitations seen in the previous generation neural computing. But if we have a previous generation neural network structure with a thick middle layer, multiple middle layers, that can also give rise to deep neural characteristics. So this is the difference diagrammatically. A multi-layer perceptron with one middle layer might be called a shallow network, but if we have a multi-layer perceptron with many middle layers, more than 3 at least, that we can call to be a deep structure. So with multiple middle layers, we will find that the network's learning capability becomes better. So this way, when we have a thick layered network, its feature learning becomes better. This is the consideration with which the shallow networks started to transit towards deep networks. So for the face learning, face recognition or face learning cases with more number of layers, the face shape capture, the face boundary capture becomes better. The features captured from the faces become better layer by layer. So hence, with a thick middle layer, feature learning becomes better, detailed. Therefore, a thick middle layer network is called a deep network. So quite frequently there is a question coming on. A question might come when we can call a network to be deep. We can call a network to be deep when it has several nonlinear feature transformation layers. So deep learning therefore need to facilitate learning hierarchical representations. That means that if we are recognizing a vehicle, the first layer will be dealing with the low-level feature. Next layer will be dealing with the mid-level feature. Next layer will be dealing with the next high-level feature, and then finally will drive a trainable classifier. So we can say that deep machines are primarily reliable for representing certain classes of functions, particularly those suitable for visual recognition. This is the basic consideration with which deep networks started. And further, deep networks are not dependent on a specific hardware type. So most of the functionalities are provided or are streamlined through software. So therefore, that hardware dependence is removed from the picture. The deep functionalities come from several layers through which the network grows. Then we see that in the case of the deep networks, a trainable feature hierarchy is developed. So this trainable feature hierarchy is linked with the capture of trainable feature representations. So each of the stage will have a different trainable feature. So they will come through multiple transformation. So if we are doing a face recognition, we may see that the basic feature capture will start with a pixel. It will move to an edge, then to a text-on motif, like that. Then for a text, we will start with a character, then move on to a word, then go to a word group, then a clause, sentence, like that. Same way for the speech, we will see it starts with a sample, spectral band, sound, phoneme. So in all these cases, the deep structures facilitate a trainable feature transform. And this particular trainable feature transform, lately we see, are capable of dealing with both static and dynamic samples. Dynamic samples means time varying samples. So both static and dynamic samples can be dealt with by these type of trainable feature transforming layers. Further, the trainable feature hierarchies support an end-to-end learning. So so we can find that the feature transformation is quite beneficial for supporting a continuous learning. So so the different modules the different modules will be continuously forming the feature sets and will be passing on to the next layer, as we see with the case of the biological brain. So all this development took place because we found that there were problems with the previous generation networks when trained with the backpropagation. Despite the fact that previous generation networks had multiple layers, and the local minima problem was generated, slow convergence to the optimum value, and required level data. So therefore, with the use of the deep learning, the generative method of doing the training came into the picture, which is not dependent on level data. So so people thought that multiple layers would make the sense to learn features despite not being fed with level data, as this was the case, or this is the case as we see in the brain. So brain will have 6 layers forming the monocular region, which will be responsible for capturing the optic radiations. Then there is a thick magnocellular structure and a parvocellular structure. These have their own forms of representation developed and passed on to layer by layer. So as seen in the brain's case, this layer by layer learning became the key part in the formation of deep networks. So many layer neural network structures were thought to be capable of learning through underlying features and feature logic, and therefore are thought to will be generalizing well. But very recently, it was found that it may not be true. Therefore, people started to work on structures that led to the rise of the deep learning. So the best way to train multi-layer neural networks was found to be something like this. So the first layer will be doing the training and will be completing the learning first, and then it will pass on the learned samples to the next layer. Then the next layer will be driving the next layer. So the training representations or the representation knowledge developed during the training will be passed on layer by layer. So this way, the multiple layers together guaranteed that each of the layer contributed towards the depth of the feature captured, the details of the feature captured. So therefore, this particular thick layered network became the beginning point, as I have talked in the last class. Then the recurrent network was found to be quite reliable for dealing with the time varying signals, which is also used with the communication domain or the wireless communication domain, because it can capture the context and can deal with the dynamic signals due to the presence of the feedbacks. Then further, convolution neural networks remain to be the backbone of the deep learning platform for its capability to learn features in details. Now let's see how are the machine learning tools being configured for the wireless communication domains. We find that till now, till the 4G and the transition to the 5G, we are seeing that machine learning tools are being used for power control in the base station. Then we are seeing machine learning based spectrum management, We are seeing the use of the machine learning based backhaul management. We are seeing machine learning based cache management. We are seeing machine learning based computation resource management. We are seeing machine learning based networking. We are also familiar with the machine learning based mobility management. We are seeing machine learning based localization, and we are seeing machine learning based waveform recognition. Now we start with the machine learning based power control. Now this power control requirement comes from the challenges that are seen in the channel. Now the wireless signal and the related network comes across a wide range of variation. Now these variations are related to the characteristics seen in high-speed transport, mass gathering premises like the shopping malls, railway stations, and so on and so forth. Therefore, there are slow-moving customers, fast-moving customers. So we can find their fluctuations of the signal due to the movement of the subscriber. Then there are characteristics in the meter level, which will be controlling the path loss factor, shadowing, fading, so on and so forth. Then finally we find there are characteristics linked with the wavelength and the frequency of use. So all these variations are continuously learned by machine learning tool, and that way the power control, the power management, the power or transmission power management shall be regulated or is regulated by the machine learning based systems. So we therefore need to develop capabilities that has specific hierarchical characteristics that can be used for prediction, which is the basis of learning-based wireless communication. So at the scenario level, we can use self-organizing networking, where optimization and load management, troubleshooting, service forecast, and push are part of the system. People have reported the use of support vector machines and k nearest neighbor techniques for doing the classification and clustering. Then at the meter level, for dealing with the fluctuation of the signals, for shifting between frequencies and tuning between the antenna structures and the control of the power, the challenges are found to be medium, and there the main task is of the regression type, and there people have found that most of the neural structures are quite suitable for that. Then if the consideration comes to the wavelength domain, where the physical layer comes there in the picture, for the use of the channel fading, prediction of the channel fading type, then frequency shift of then frequency slot capture or frequency occupation, then spatial and temporal details, then self adaptation for the frame and the pilot, and the shift between different MIMO structures. We find that a specific deep neural network type called long short-term memory is used for the purpose, and its challenges are quite considerable, and it is mainly a prediction-based method. So therefore we find that when And the shift shall be towards the 5G. The networks shall be data driven, because the network core will have a AI component that will continuously learn the network's behavior from the data received, and that way will tune continuously the requirements of the tune on to the requirements of the subscriber, and that way manage the capabilities of the network and the resources. Now, we find that deep learning networks are quite commonly being used for level mobile study of the data received from the subscriber side. Now, these are coming from the call detail record, and are linked very closely with the network prediction, traffic classification, and call detail record mining. So we find that deep learning this way has come into the core of the computer networking domain, are being used mainly for the network requirement predictions. Traffic classification is part of this setup. Call detail records are being dealt with by the deep learning network, and it supports the power user by dealing with a set of variables for predicting the network load, builds new knowledge, validates the tool, and sets up requests for network load prediction and load balancing. It further is very crucial for business subscribers because it can set requests for load prediction, and that way resource pre-allocation. Now there is a tool by the name of the SAP. There is a SAP tool for such sort of a purpose that can deal with this sort of network state prediction. So network planners use this SAP tool for dealing with different network conditions. Now, as part of the networking management or network prediction, deep learning tools mainly provide network state prediction. So it builds the pattern of the network, load, performance, quality of service, and so on and so forth. It will leverages say highly on the heterogeneous data like weather, the coverage locality, day and time, user and the app data, and so on and so forth, and provides user-friendly visualized outcomes of the network state versus time. So many of the network state variation with time will be coming with these predicted states. So these also will require a huge dependence on the machine learning tools. So how the network traffic prediction is done with the help of the deep learning tool? Here is a structure. There is a framework called the SNOT, which is used for lightweight network intrusion detection. So how this system works, we can see from this diagram. So first, from the network backbone, the traffic that will come that shall be passed on through a sniffer network. This is a machine learning network. Then this will pass on the data to a processor. So the preprocessor will help to form a snort detection rules. So the snort detection rules will be required for flagging the network content. So when the snort plugin will give the packets, those will be decoded, and then the decoded packets will be passed on to the network for doing the passed on to the machine learning tool for doing the classification. Now this can be done by the use of machine learning tools based on support vector machine, fuzzy logic, decision tree, then a few hybrid combinations and feed forward networks. So these are trained to make detection false or true, and these will be done by the help of the snort rules that are set beforehand from the network traffic. Now, network, since I had spoken about that, the network traffic prediction is a big thing or is a very commonly done thing by the use of the deep learning tools. So the volume of data traffic sent through the mobile networks varies throughout the day and week. Thus the network will be facing variation of traffic flow and demand. So the load management will be a continuous task at the backbone, and it is a part of the core network. So if the network people gets a prediction of the load variation beforehand, the back end system capability can be scaled up or down depending upon the requirement. It will help in minimizing the maintenance cost and the power consumption, and it will be contributing significantly towards the optimization of the resources. Similarly, these sort of deep learning based network prediction tools are used for network planning also to fix the layout of the network. So now a part of the network's traffic is the call detail record. So from the call detail record prediction, the nature of the customer, the subscribers requirements, preferences, the activity of the customer, these things can be figured out. A profile of the subscriber can be created. That way the subscribers requirements can be fulfilled. So how a machine learning based system develops or will use the call detail records for developing a subscriber profile, this particular layout shows. So call detail records will keep an eye on the visitors of a particular locality. So if a person comes from a foreign country, so that person's trip will be figured out. So number of trips completed. So if there are specific tariff considerations, and if the customer prefers a special type of services from the network, those shall be also figured out. Then if the subscriber is of that particular city, so the subscriber's requirement and traffic considerations, while the subscriber goes from a source to a destination through a road, so depending upon the times of the day, how the preferences of the subscriber requirements of the subscriber varies, these will be tracked, and that way for the subsequent period of time, the customer's preferences will be predicted beforehand, and the resources required to suit the subscriber's requirements will be provided, managed. So this helps the network to plan and that way facilitate the pre-assignment of resources required to fulfill the subscriber's requirement. So these will be tracked continuously by the machine learning based tools deployed at the back end of the network management setup. Now, as part of the wireless networks nowadays, people find that say the data coming from the apps through the mobile networks are becoming very very critical factors. Now, these are related to the diagnostics of a person, medical record of a person. These can be linked with certain pattern recognition problems, dealing with financial transactions and all that. And sometimes these are linked with natural language processing and automatic speech recognition problems. These are continuously dealt with by the use of machine learning tools. So these have become a part of the wireless networks. Now, we find that a very common app is the IBM Watson, which provides lots of continuous data recording and then passing it on to the destination with details which can convey the medical and patient data. So this is quite beneficial for maintaining a continuous link between the patient and the medical professionals. So this is a critical requirement that can give continuous support for persons with special requirement. This complete facility is based on the machine learning tools which are deployed as part of wireless networks. Now, here is a setup for a machine learning driven mobile healthcare system. So a person's details of the treatment, medical treatment, and the recommendations can be coded or can be transformed to some computational format, which can be hard coded, that can be passed on to the system and made the system to learn in the supervised mode or in the reinforcement mode, so that that particular system can learn and figure out the normal state, risk state, and the critical state, and that way continuously send the details of the medical state to the medical professionals for support where and when required. Now, we see that as part of the mobile network, the pattern recognition systems are developing and are being used. These will take the data for first training the system, and once the system is trained fully, the system is capable of dealing with correctness required to help a person where and when required with support of the pattern recognition type. Then, as part of the pattern recognition capability, mobile networks have developed significant capability to figure out fraudulent practices. So machine learning driven fraud detection in mobile networks have become a very common practice nowadays, and this is used by the financial sector, mainly the banks, for detecting fraudulent transactions. So when we use a card, debit card or a credit card, the first a validation, a verification is done. So once that verification request is made, that will go to a machine learning system that will record, first note the transaction request, will figure out the cardholder's profile, will pass on the request details to an authentication module, response module, then the transaction and score details shall be created or figured out. That shall be passed on to a case creation module, which will be verified by the use of the expert rules. So if then a workstation meant primarily to hold the records of true and fraudulent transaction requests shall be brought in the picture to verify if that particular case is true or false. So depending upon the response given by the workstation meant for the purpose, a case management database will be continuously created, and this will be linked further to the expert rule base. So if all things work well, if all things work favorably, then the transaction shall be processed. If at some point of time there are doubts raised, that particular transaction will be considered to be a fraudulent request. So this way, we find that machine learning based fraud detection in mobile networks have become a very common practice used mainly by the banks and the financial companies to deal with fraudulent or to prevent fraudulent transactions. Now, a significant part of the deep learning has gone into the development of mobility profiles of the subscribers as part of wireless networks. Deep learning networks are trained to track the mobility of the subscribers. So when a person goes from one location to a different one, where the person stops, where the road that the person takes, the speed that the person takes while moving from one point to a different one, the weather at that point of time, the stoppages where the person took, the places crossed, the apps used during the transport or during the travel, the real estate sites that were crossed during the transport, what were the different developments that took place during the transport, the spending, what was the type of spending done, if any, by the subscriber, the Wi-Fi services taken by the subscriber while using the free Wi-Fi service, if they have switched on to some different telecommunication company, and what was the traffic profile during the transport from source A to destination B. All these details are continuously tracked by deep learning resources that are deployed as part of mobile networks. Now, this has come up as part of that vehicular networks. So vehicular networks with such sort of profile creation in the highways mainly give capability to the driver to know beforehand the traffic variations, the route details, disruptions in the route. And then the vehicles can share sensor data, can have weather details, so on and so forth. So it has helped considerably to ease traffic and get rid of the difficulties while traveling from one place to a different one, but has also helped in creating user-specific profiles in the network's backhaul database management. So how the machine learning tool uses the mobility prediction and how the network will optimize the resources. Here is and there is a setup. Now with this particular setup, each of the subscriber, network develops a temporal profile. Temporal profile means the profiles that are varying with time. So since the subscriber goes from a place to a different one, from point A to point B or source A to destination B each day, so that way the travel during the travel, the time dependent or time based preferences are recorded. So now while this recording takes place, this part, or while this tracking takes place, the preferences are held at cloud servers at different vehicular network locations. Now, to start with the profile creation, first a monitoring will take place. During the monitoring part, the machine learning tool will start to learn or learns continuously the user's preferences, and then will start to optimize the network resources with temporal dependence, or with temporal components, or time dependent components. So here different parts of the clouds are used to learn continuously and store the learned representations, which help to create the profiles of the subscribers and the preferences. So the backhaul network that way will continuously readjust the network's resources to facilitate the subscribers' preferences. Then one more very critical part, where deep learning tools are used as part of mobile networks, are the localization, is linked with the localization, which is linked further with localization services. So when a person goes from a place to a different one, the route that the person takes, and the preferences and the activities of the person, since are continuously monitored, and the user preferences are developed. Now those particular user preferences help to develop localization footprints. Localization footprint means what the user is doing at what location. If it is done on a regular basis, then those are marked. Those are noted. So if a person going from source A to destination B, then if there are points 1, 2, 3, 4, 5, 6, 8, 9, 10, so he might that particular person might shift to a video call between points 2 and 4. And say again, the person may start a video call between the points 7 and 9. So these are localization services. The network will start to know that this particular subscriber has preferences, has specific requirements while traveling between these points and that point. So that way localization profiles are created, localization footprints are created, and resources are managed that way. So for this type of profile creation and resource management, machine learning tools have played a very significant role. Now, so one of the very noted localization service is the cab service that we all use, the radio cab service that we all use. Now, this is a very good case study of localization services driven by machine learning tools deployed as part of mobile networks. So if a subscriber makes a request for a cab service, the machine learning tool will try to find out where are the cabs. So location details will be picked up. Once the location details are picked up, those will be shared between the between the drivers. The driver that is nearest or is most likely to receive the request will then be given the service to be completed. So this sort of localization services linked with customer satisfaction, financial transaction in secured ways, while sharing the customer and the driver's profiles and recording all the developments in real time are facilitated through the mobile networks by machine learning driven localization services. Then there are specific deep learning provisions as part of wireless networks, as part of mobile networks, which deal with wireless sensor networks. Now, wireless sensor networks mainly are seen while dealing with say online traffic load prediction, traffic management, traffic detail projection, and while dealing with roadside development. So if a car crash takes place, so that particular development can be picked up by roadside sensors. For that, wireless sensors are there. Those can be cameras with tilt and zoom facility. Those will be controlled from the mobile network, mobile station, and can be as part of a vehicular network. There can be similarly proximity sensors and lane crossing sensors. So these sensors, since are part of the mobile network, the details coming from the sensors, monitoring of the sensors, and placing a supervisory control through the sensor network has become a machine learning driven part of the network. So these sensors can be in the centralized manner or deployed in the centralized manner. The control can be centralized, or these can be deployed in a decentralized manner. Their control can be also in a localized or decentralized form. Now, these are used primarily for localization services and then providing predictions. So therefore, wireless sensor networks management, monitoring and control through wireless sensor networks are being driven through deep learning tools and are very significant components of wireless networks, mobile networks. So we see that wireless sensor networks have become more and more diversified, and these require high data rate support because many of the wireless sensor networks run multimedia. Then for performing channel quality management and composite metrics derived from the wireless sensor network, from that a channel rank the channel's behavior is figured out. The channel state is captured, and requirements of the channel, since is quite significant, because the link reliability of the system, the quality of the service, quality of service of the network is quite critical. Therefore, the wireless sensor network is used significantly to find out the channel rank metric, measurement metric. So this gives the received signal strengths, the link quality, and this will help, or this helps the network to tune the network parameters for better signal and coverage. So how this is done? So here is a depiction. So while there are there are links between the base stations. A person takes a route from source 1, source node 1, and will terminate at source node 2, or can make simultaneous transmissions to source node 3 and source node 4. So while the traffic takes different paths, so the preferences and the requirements of the subscribers, and how the channel is behaving, this can be continuously figured out by the use of the wireless sensor network, and the previous behavior of the channel in those locations while going from source node 1 and terminating at source node 2 and source node 3 and source node 4 for different types of transmissions. And the wireless profile, as known previously, will require specific responses, and management of the resources will be managed by a machine learning based setup. Then there is one more very significant part dealt with by the deep learning tool, that is linked with the network control. These are related to the network optimization, routing, scheduling, resource management, radio control, and similar type of things. So machine learning tools are used mainly for the network resource management. So if load builds up, traffic load grows at one specific location, where the cell site is being flooded by request and data flow, and there are several nearby cell sites lying free. So the traffics will be rerouted through the free base stations, through the free cell sites. So this will require a proper synchronization and a smart management there at the backhaul. And so routing details, shortest route path search. So this will be also done there at the back end for all the subscriber calls, and the route details, shortest route details shall be figured out, and the relevant resources required to meet the request will be linked with the network resource management, which is carried out by the machine learning tool, and the specific services required, which are scheduled by following the subscribers' requirement profiles, that can be also dealt with in a very optimized manner by a machine learning driven framework, and this is done in conjunction with radio resource management and radio control facilities, which are as part of functionalities linked with the machine learning tools. Now here is a setup that shows how this is done. So now this is a part of the 5G network planning. We see here that in the first part there will be a common network function visualization platform. So on top of a hardware layer, there will be several built-in AI blocks. Those AI blocks will be given given the freedom or the capability to find out how the network is behaving. If there are probable hardware failures or software bugs have come in, those can be also detected. So at site A, with a common network function visualization platform with several visualized functions, a AI driven block will continuously learn the network's capabilities. Then with that particular layer, or with that particular capability, if there is a failure by not disturbing the network flow or the traffic flow, the AI driven functionalities will take over, which will guarantee a restoration of the services. So a disruption is prevented. Restoration services come into the picture, and this back end management of not disturbing the traffic shall be carried out by what is called software defined networking. These are part of the 5G framework. Software defined networking and network function visualization, they work together as part of AI driven blocks modules. So once a network failure was detected, restoration services were deployed. So next thing will be fast preservation of the visualized function before fatal situations develop. So this is facilitated by the AI driven blocks. So without a catastrophic situation developing in the network due to a hardware or due to a hardware failure or a software bug, the AI module prevents disruption. So this shall be part of an AI supported network management system. Then there is a very commonly used deep learning block for network security, where say fraudulent connections, malware detection, denial of service, and so on and so forth are detected in the mobile network by the use of deep learning and machine learning techniques. This considerably raises the network security level. Then now mainly the deep learning tools and the network security structures work together, and say impersonification links, spoofing attacks, cyber strikes, ruse users, then say denial of service and jamming attacks. These are all detected by a deep learning tool, and their classification as malware, virus, trojan, privacy leakage, malware, and DOS cyber attacks are carried out by the security apparatus, which is a AI driven block. So this can be done by the network layer continuously, and it helps in tracking the IP locations. What are the protocols followed, the file types, frame length, frame number, the host port number. These are all captured, and specific profiles created. Now, if these are linked to specific apps, specific users at specific times, those particular details are also captured and classified by several machine learning based tools. So this gives a very reliable capability to the network's security. Then we find that deep learning tools are used for signal processing as part of the mobile network. We see that deep learning tools are being used for as part of the MIMO system for predicting the channel states. These are used further for the detection of the modulation and the data types. So how then there is a technique called blind source separation. So the sources that are not required, the sources that are degrading the signal strength are separated out by the use of the machine learning tools. that use joint discriminative training by the use of deep neural network or deep recurrent neural network, and use time frequency masking techniques for dealing with magnitude and phase spectra variation has become very reliable to raise the quality of service. Now we see that blind source separation are used in all types of multi-SS techniques, right from CDMA, frequency hop, then the OFDMA, then CISO and CIMO and MIMO setups, topologies, wireless sensor networks, cognitive radio networks, and RFIDs. These are also used for capture of the required signal, modulation, classification, suppression of the ISI, then interference cancellation, and then the direction of the arrival, calculation, multi-object detection, spectrum sensing, and so on. So there are several practices, both linear and non-linear, through which blind source separation techniques work. So what are the next generation machine learning tools, machine learning driven network functionalities that will come up? These are network data monetization, then the use of the IoT as part of the mobile network and computation as part of it, then mobile crowd sensing, mobile social networks, mobile blockchain, and Internet of Vehicles. These will be the next generation of network services that will be managed by the machine learning tools. So as days go by, the deep learning tools and the AI tools are being tailored to meet the requirements of the customers for mobile devices and systems, distributed data containers, informed and changing mobile scenario. So I would like to conclude that AI tools form the backbone of the provisions required for reliable management and control of the networking backbone of the next generation wireless networking and the current wireless networks. Deep learning tools have a range of applications that are spread all throughout the physical to the network layer. The goal is to optimize the resources and make the link reliable. So before I end, I would like to request the participants to raise one or two quick questions. Sorry.
Sir, in the chat box, there is a question from Vijay.
Yes.
What is the problem lies behind the installation of 5G near aerodromes? Okay.
Say now the main thing is linked with the frequency bands. Now 5G's spectrum is quite bigger. There are several frequency bands, and some of the frequency bands are coming to the frequency bands used by the flights to measure the height. The radio, they call it the radio altimeter. So they use radio frequencies to find out the height. So the 5G frequencies that the US is deploying falls close to these frequencies that the flights use for measuring the height. So many of the pilots fear that due to the deployment of the 5G with those frequencies, the flights will fail to figure out the height properly, and that way catastrophic situations will be created. That is the only fear. So, but the US government is now saying that if they deploy 5G towers, those will be not close to the runways, 2 to 3 kilometers close. That's one thing, and they might jam or block those particular frequencies in which the flights work while figuring out the height of the travel. That is the reason.
Thank you, sir.